Welcome, my dear J Warriors. It's time for a power packed 5 days, 15 sessions, 5 chapters each from every subject. And starting off with physics. And after this, Diksha ma'am will take up chemistry and Namrata ma'am will take up mathematics on the channel. So we are taking up current, electricity, and power packed 1 hour classes here and there. All right. And we are going to go revise the concept and immediately start off with problem solving. And yes, we are taking up PYQs. This is your Captain Shreyas on the Vedantu J English channel. Get set, go, guys. If you have not yet marked your attendance, like the session right away, right now. And if you are still, in that zone, oh, I have not yet subscribed, only where I will like, guys, first of all, subscribe because you are getting all the important updates, content, academic strategies, tips, everything, the one and only J English channel, guys. And yeah, do not forget MVSAT last 2 days are remaining. Online it is at the comfort of your home. You can win prizes, scholarships, trips, iPads, tablets, headphones. Just give the test plus the study material which is going to given to you absolutely free of cost, and separate tests for 11th and 12th standard JEE NEET, and even for 7th to 10th grade, even for droppers, separate pattern tests are there. It's all online. Make sure you utilize this 90 minutes in the best possible way. The link for it is there in the description box of this particular video. All right. So let's begin with the class, and I'm pretty sure you're all excited. Where are we? Oops, this is KTG. Where is current electricity, man? Current. Yeah, here we are. Current electricity. There you go. And nice to see all of you with full excitement. Main character energy. Let's make history. I don't know which one to choose. I'll just choose this one. Yeah. Note taking not matters, Pranav, because I'm going to give you the PDF. So concentrate on problem solving. Listen to this lecture like a movie. Even if you don't write one single word, it's okay. Or at least for the problem solving part, maybe you can scribble little bit, but notes, everything, I'll give it to you in the PDF form. It will be there in the description box. MVSAT link is there over here. Register for it right now. Just 2 days, guys. It's online. Yeah. You need 90 minutes to give this particular test, right? So let's begin with the revision. Hi Umadevi, Rasik, Pranav, Bhanu, welcome. Yes, Rajkumar, Vinod, R2L, Mukundan, good evening, my dear warriors. Starting off with the first few concepts. Current. Current is basically when charge flows, how quickly the charge flows in a time. Q by T gives me the value of the current. But remember, sometimes the current might keep on changing, fluctuating. So if you want the instantaneous value, then you take the derivative of the charge with respect to time. That gives me the current. If you integrate current with the time, you will get the charge. Keep that in mind, right? Current is how quickly the charge flows per unit particular time. That's what it is. It's a scalar quantity, unit is amperes. So current is dq by dt. When something is derivative, the reverse quantity will be integration. So charge will be integration of current with respect to time, right? Don't worry, you're going to get all the PDFs, everything. So just watch it, revise it. If you have your flashcards or notes, use it alongside with this. Next important concept is drift velocity. Now, when you take a conductor, current is flowing means charges are flowing. So the charges will be moving on an average with certain speed. That is called as your drift velocity, right? That is called as your drift velocity. So that drift velocity VD can be calculated by this formula. Current is NVIDIA. NVIDIA graphics card company. N is how many electrons are there per unit volume of that wire, per meter cube, per volume. E is the charge, which is 1.6 10 to the power minus 19. A is the cross-sectional area. Now, by the way, if you take area below the current, then that current per unit area, that is called as the current density. That is called as the current density. Density of the current density, J. Alright, keep that in mind. So J is current per unit area if you take A below the current, right? That is the next formula. Also, there is another formula for drift velocity, and that is EEM by tau. Now, what is E by M into tau? What is small e? It is the charge of the electron. Vd is your drift speed, the same drift speed which I told you over here. Okay, the same drift speed which I told you over here. This capital E is the electric field inside the wire. Why is there electric field? Because that field will push the charges to move in that wire. So that is why there is an electric field inside the wire, because you have connected a battery, positive, negative, high voltage, low voltage. Electric field will go from high voltage terminal of the battery to the low voltage terminal of the battery. M is the mass of that electron. Tau is the relaxation time, which is, or mean free time you can say, that tells you how frequently those electrons are colliding with each other and how much time are they spending freely without touching each other. So when an electron collides, by the time it collides with the next one, the time between these two collisions is called as the mean free time on an average. Okay, because they keep on colliding with each other. Is that clear, everyone? So you can use any of these two formulas for drift speed depending on the situation. Current is NVIDIA, or drift speed is EE tau by M. EE is basically, charge into field, and M is the mass of the electron. All right. So having said this, the last few things over here which we need to discuss is mobility and current density. I already told you it's current per unit area. So current density, J, is nothing but current per unit area. I think it is there on that previous slide only, which I told you. Okay. And yes, there. Yeah, current density is current per unit area. And this factor of mobility, drift speed per electric field, very important. Mobility also comes in your semiconductors chapter, by the way. So if you have applied some electric field in that wire because you have connected a battery, these charges will move. So how quickly they are moving for that field defines how mobile they are. That is mobility. Drift speed, that is how quickly they are moving per unit electric field. That is your mobility. Is that clear? So that is mobility, my dear warriors. Unit is also mentioned. It mentions how quickly electrons move when an electric field is applied. Okay, you can use the same formula of drift speed which you had found out before, EE tau by M. So if you divide it with E or bring that E below, E tau by M becomes your mobility. E tau by M becomes your mobility. Okay, now let's go to the next few terms, which is resistivity, Ohm's law, and the temperature dependence. Okay, and then we'll start solving problems. Ready for it, guys? Yeah? Show some Josh, and if you have forgotten to like the session, please like it right away right now. Okay, so all these notes will be given to you. These are like quick revision slides. You can take printout also and you can revise it for your examination, right? So next is Ohm's law and the definition of resistance. Ohm's law says that voltage is proportional to the current, and that constant of proportionality is what we call as the resistance. So voltage is proportional to the current, the constant is called as the resistance. It decides how much current will flow for that voltage. And this particular resistance depends on the shape, the size, and the material of that wire or that conductor. So you will see the resistance depends on length of the wire, how long it is, area of cross section of that wire. Okay, so size, shape, everything matters. Also rho, that is basically resistivity, meaning the material. So if a material like copper is there, it will have very less resistivity. That means the resistance will also be less because it will conduct very easily. But if you take rubber, wood, they are very bad conductors. So that means the resistivity will be very high. Resistance will also be very large. So it will not conduct electricity so easily. So material, length, and area together define the resistance of that conductor, right? So R is rho L by A. R is rho L by A. Rho is the resistivity. V is equal to IR. That is very important. Now, also remember that the resistance changes with temperature. All of this was fine if the temperature is constant, but if the temperature changes, then rho will change, R will also change. Why does it change? Because if temperature increases, then the electrons which are inside the wire, they will start hitting each other more frequently because of increased thermal energy, and they will collide and they will increase the resistance. So resistance increases with temperature for metals, or basically conductors, and the formula is R is R naught 1 plus alpha delta T. R is R naught. R naught is initial resistance. Alpha is that factor which defines how quickly the temperature will affect the resistance. Delta T is how much you have changed the temperature. Let's say I went from 10 degrees to 30 degrees. So change is 20 degrees. R naught is original temperature. So at 10 degrees, what was the resistance? Maybe it was 50 ohms. So that 50 will come here. So at 30 degrees, how much is the resistance? Maybe it might become 55 ohms. That's what it will be. Alpha is that number which is called as the coefficient of thermal resistance, which tells me how sensitive is that conductor for temperature. But keep in mind, for semiconductors, this alpha is negative, meaning when you increase the temperature, the resistance will go down. Okay, so resistance goes down for a semiconductor because the manner in which semiconductor functions is completely different than a conductor, because in a conductor already so many electrons are there, so adding more electrons with more energy will complicate matters and will make it difficult for the electrons to move. But in a semiconductor, barely any electrons are there, so when you increase the temperature, more electrons will participate in the conduction, which makes it easier and reduces the resistance. That is what happens, okay, for a semiconductor. So also keep in mind, Ohm's law is only valid for ohmic devices, meaning voltage is proportional to current, is valid for copper, nichrome, basically most of the metals. They are called as ohmic devices, but there are many devices like vacuum tubes, semiconductors, etc., where voltage keeps on changing with current and not linearly, non-linearly. So they cannot follow Ohm's law. That is why they are called non-ohmic devices. They are called non-ohmic devices where current and voltage are not proportional to each other, like diodes, lamps, vacuum diodes, okay, vacuum tubes, etc., semiconductor devices. They are all non-ohmic in nature, where they will not follow straight line curves. Remember that straight line slope in a way defines how much is the resistance, right? So how you can see over here, this is low resistance because there is more current for less voltage, but this is very high resistance because even for such a high voltage, the current is barely there. So the slope also decides how much is the resistance of that device. Keep this in mind. So it's time to solve some questions. Current passing through a wire as a function of time is given. The charge that will flow through the wire from 1 second to basically some seconds. Okay, that is the question. Okay, everybody, if you want to scribble and solve it with me, please do it, because otherwise theory part you are going to get as slides PDF. Okay. Now, if current is given, charge is asked, we all know that current was dq by dt, So if I shift it, you will see dq will be nothing but current multiplied by time. So integrating both sides, I'll get integration of dq will be nothing but integration of current. Current is nothing but 0.02 into t plus 0.01. This whole thing is the current into dt. Now the limits are very important. From 1 second to 2 seconds, this will be from 0 to the final charge. So integration of dq will be q only, and lower limit and upper limit will be substituted as follows. This 0.02 is a constant, will come outside. So I'll just have integration of t times dt from 1 to 2, and plus 0.01 again comes outside, just integration of dt from 1 to 2. That's it. So therefore I will get q is equal to 0.02 multiplied by t's integration will be t raised to 2. So put 2 raised to 2, then you will put 1 raised to 2, whole thing minus and divided by 2, of course, because t square by 2 will be the integration, plus 0.01. Integration of dt is just t. So first put 2, then put 1 and subtract both of them. See what are you going to get. 2 will cancel, so this will become 0.01 multiplied by 2 square is 4, 4 minus 1 square, which is 1, which is 3, plus 2 minus 1 is 1, 0.01, of course. So this will become 0.03 plus 0.01, right? So which will make it 0.04 coulombs, which is obviously option number 4. Yes, very good, Aminav. Amazing go. I'm so glad, Rama, to see you all. Hi, Kavita. Yes, your captain is here. Hi, Rasik. Hi, Ria. Welcome. Ibrahim. Good evening, Rajkumar. Thank you for all that fire emojis. Next question on your screen. Here it is. Remember, these are rapid fires. 1 hour compact, concise, to the point sessions, right? Which of the following resistivity versus temperature curves is most suitable in a wire bound standard resistor? Okay, resistivity versus temperature is very apt for a wire bound standard resistor. This is very important. Standard resistance for standard resistance, we all know that resistance is R naught 1 R naught 1 plus alpha delta T. So instead of R, we can substitute rho L by A. This will be rho naught L by A, and this will be 1 plus alpha delta T. L by A will cancel. Resistivity will be resistivity initially 1 plus alpha delta T. This tells me it will be a straight line graph because it is a linear equation. It is a linear equation. The power of temperature is 1. The power of temperature is basically 1. So it has to be a straight line graph. So this is the right answer. And because it is a conductor or a resistor normally, so it will be positive slope, because when temperature increases, resistance should increase. If it was a semiconductor, then the graph will come down. Because when temperature increases, resistance decreases for a semiconductor. This was a standard resistance, so it will increase. Is this absolutely clear? Okay. So this would be the graph for semiconductor, by the way. Anyways, option D. Moving on to the next question coming up on your screen. Here it is. Which of the following graph correctly represents the variation of mobility of electrons applied to the electric field in a metallic conductor? Very interesting. Mobility they have asked. Okay, what is the mobility going to be with the applied electric field? Now, if you remember, mobility was nothing but drift speed by electric field, and drift speed was nothing but E by m into tau. Now E got cancelled and we got E tau by m. E tau by m is nothing but mobility. Now if you notice over here, very easily it is seen that mobility does not depend on electric field. Okay, it is basically independent. It is independent of electric field, because E and E just got cancelled. So it should be independent. That means option 3 is right, because it will not change with it. It will be constant. Option number 3. Very good, Rasik. Amazing, man. Amazing. Yeah. Very good. Amazing. Moving on to the next question coming up on your screen, and here it is. The drift velocity of an electron for a conductor connected in an electrical circuit is Vd. The conductor is now replaced by another conductor with the same material, same length, but double the area. The applied voltage is also the same. The new drift velocity will be how much? Very interesting, guys. What will happen to the drift velocity if certain things have changed? Okay. So one thing what we can do is see how the resistance will change. So because you have this particular conductor, and maybe the resistance might change, maybe because of that current might change, and maybe because of that drift velocity might change. So this is your battery which is connected to it. Okay, so the applied voltage remains the same. The drift velocity will be how much? Okay, so we know current is nothing but NVDR. Current is NVDR. What is current? Using Ohm's law, V is equal to I into R. Therefore, current is voltage by resistance. But wait a minute, resistance is rho L divided by A. Therefore, my current is, area goes on the top, voltage into area divided by resistivity into length. So we'll take this and put it over here and see what do we really get. Okay, what do we really get? So on the left hand side, for the current, I will substitute VA, voltage into area, by resistivity into length. And on the right hand side, I'll just keep NVDEA. See what is happening, guys? The area and area just got cancelled, and I will now get the value of the drift speed, which is voltage and the whole thing divided by resistivity, length, into N into E. N and E will go below. That's what it is. Voltage is the same. You can see that very clearly. It is mentioned over here. Voltage is the same, so nothing will change. Material is also the same. Yeah, same material. So resistivity will be the same. N will also be the same. And same length is also given. So length is also the same. Charge is a constant. So nothing changed. So this will obviously be a constant. It will not change because you change the area. Hence, the answer should be option number 1. Very interesting answer. Yes, Spencer, the answer is 1, my dear. Very good, very good. Proud of all of you guys. Okay, understood? So these kind of tricky questions have come in your JEE exam. As you can see, everything is just these formula based. So if you are studying these formulas, if you are going through the theory, that's more than enough for solving these questions. And it doesn't take much of time, honestly. Okay, so I think I have kept a homework question for all of you. Please solve it after the class. The solution is there on the next slide. You can download the PDF by tomorrow. Okay, all the PDFs will get updated. Okay, very simple. So at this temperature, this is the resistance. At that temperature, this is the resistance. So then what is it when they are connected in series and parallel? Very straightforward. Anyway, so let's do the next concepts and the problems on that. Resistors in series and the power formulas. When resistors are one after the other, they are in series. But when resistors branch out sideways, they are basically in parallel. And the effective formulas for series, you just add them. But for parallel, you add the reciprocals to get 1 by the effective resistance, like over here. Now keep in mind, when the resistors are in series, what is same? And when they are in parallel, what is same? When they are in series, the current is the same. Yes, the same current will flow through all the resistors, but the voltages are different. The total voltage will be how much voltage is there in this, this. You add them all, you get the total voltage for series. But for parallel, the story is exactly opposite. What will happen? That yes, the equivalent resistance is 1 by R1, 1 by R2, like that. And you will see that the voltage will be same. So whether you take this resistor, this, all of them will have the same voltage across all of them. Yeah, because left side terminals are connected to one thing, right side are connected to one thing. So same voltage difference for everyone. But the current will get distributed in different branches. So whatever current will enter will be I1, I2, I3, I4, I5, like that. They will get distributed. Now talking about power, power is voltage into current, or V into I, or I squared R, or V squared by R. You can use any of these formulas depending on the situation. If I know current is same and maybe resistance is changing, maybe I will use I squared R. If I know voltage is same, then maybe I will use V squared by R. Like it makes sense. If it is in series, I know current will be same. So maybe I'll use I squared R. If it is in parallel, I know voltage will be same. Okay, so I can use V square by R. So it depends from situation to situation. All right. And you can see that whenever power is there in the circuit, power is lost in the circuit, then there will be also how much work is done in some time. Remember, power is how many joules is being consumed or lost per second. So if you wait for some time, let's say t seconds, you will get the energy calculation. So if you multiplied voltage current multiplied by time, you will get the work done or the heat lost or the energy given or the energy lost, basically the energy joules calculation. This term is joules per second. So you multiply this with time, like I square R into time, or V square by R into time, or VI into time, you get energy. Very straightforward. Okay. Joules per second into seconds will give me just joules. Will just give me joules. Yep. Correct. So I have kept that over here also. So remember, work done is voltage into current into time, or V square by R into time, or I squared R into time. Anything you can use, okay, for energy calculations. Keep in mind, there is one more formula which is looking like this: V into Q, especially useful for capacitors, because you can see current into time is nothing but charge. So if a charge will flow through a voltage of whatever volts, maybe through a capacitor or even a battery, then the work done will be just V into Q. So you can see this work is voltage into current, which is power, into time, which will give me joules. You can combine I into T as charge. So you can use this formula especially for capacitors or even a charge which is flowing through a battery. How much work did the battery do? Okay, this is especially useful over there. Okay, so these are the standard formulas which I gave it to you some time back. Now, sometimes you can see these units like kilowatt hour, okay, kWh, mAh, these kind of units being used, those are the units of energy, not of power. Because when I say kilo is basically 10 to the power 3. What is the unit of power? What is the unit of power? And hours is nothing but 3600 seconds. So power is nothing but joules per second. When you multiply this with seconds, you will get joules. Keep that in mind. So kilowatt hour is the unit of energy, joules, work, and not of power. A lot of students have this confusion. So 1 kilowatt hour, 1 kilo is 10 to the power 3. Watt is joules per second. An hour is 3600. So you multiply 3600 with 10 to the power 3. You will get the answer in joules. You will get the answer in basically joules. Yeah. Amazing. If you have watched the Roar series, this lecture will be a very good revision point and testing point for you, my dear. Okay, Hemant? All right. Perfecto. Now, having said that, yes, talking about EMF inside a battery, talking about the voltage and the EMF generated by a battery. Lot of students think EMF is voltage is EMF. That is wrong. EMF of a battery is basically, think of it, what energy will be needed if you take a charge once around the circuit to bring it back inside the battery. So that work done per unit charge is called as the EMF. And when you move that charge, you are moving it very slowly without any losses and all of that. So whatever work is being done just to move it from one terminal of the battery to the next terminal. You're just taking a wire, no resistance at all, just to move it back inside the battery. So work done per unit charge. That joules per second, work is joules, charge is coulombs. That joules per coulomb is basically called as a volt. It is basically called as a volt. Now that EMF is not necessarily the actual voltage which you will get, because when current will start moving, you will see the actual voltage will be slightly lesser than that EMF, because what you just did, you moved the charge from one side to the other negative terminal of that battery. But when that charge will pass inside the battery, it will lose some energy because of internal resistance, because our batteries are real in nature. So you will see the actual voltage will be the EMF minus IR. So if you actually measure using a voltmeter, the voltage, terminal voltage of a battery, it will be lesser than the EMF by IR. I is the current flowing through it. R is the internal resistance. R is basically the internal resistance offered by the electrolytes of that cell. Okay, keep this in mind, right? Everyone with me? Perfect. So, having said this, it's good time that we start solving some questions coming up on our screen. Here it is. Okay. From the combination of the resistors R1, R2, R3, all the three are 5 ohms and one more resistance of 10 ohms, which of the following can give you an effective combination of 6 ohms? Basically, they are telling us that, my dear, use series parallel combination, whatever you want, and just tell me which of this combination will give me somehow 6 ohms resistance. Okay, so think about it, guys. Okay, whether all of them in parallel, all three in parallel, two of them in series, two in parallel, two in parallel, two in series, or three in series and that in parallel, one of them should give it. So if you just start doing it mentally also over here, imagine this is 5 ohms, this is also 5 ohms, this is 5, this is 10. So together this will become 10 ohms. Together this will become 15 ohms. Just see how much will be the parallel combination. If two resistors are there, don't do reciprocal. Just use R1, R2 by R1 plus R2. Only for two resistance. If there are 3 or 4, then use the reciprocal formula. So this will become 10 multiplied by 15 divided by 10 plus 15. 10 into 15 is 150 and 10 plus 15 is nothing but 25. So this will go 6 times. Oh, luckily we got it in the first go only. Okay, so I don't have to check others. Guys, this was pure luck. So option number 1 is absolutely correct. But if you check other resistors, we can see it will not be correct. For example, let's say we take this. R2 is 5, R1 is 5, R3 is also 5, R4 is basically how much? 10. Okay, so these two fives together will make it 10 ohms. Now all three are in parallel. When three resistors are in parallel, use reciprocal formula. So 1 by R equivalent parallel will be 1 by 5 plus 1 by 10 plus 1 by 10. Yeah, three resistors in parallel. So this will become 1 by 5. 1 by 10 plus 1 by 10 is 2 by 10. So 2 by 10 is nothing but 1 by 5. So 1 by 5 plus 1 by 5 is 2 by 5. It is nothing but 2 divided by 5, but that is 1 by Rp. So take the reciprocal of it. So Rp will be 5 by 2, which is 2.5 ohms. So obviously this can't be the answer. Similarly, you can try other things and you will see every single time the answer will not be 6 ohms what we need. Is that clear, everyone? With me on this? Give me a thumbs up. Are you loving these kind of problems? This was asked in just 2025 this year. Imagine that student who would have got this as the first option in the exam. That student will have to check all the options, or at least three options, not four options. But your mind will say, even after checking three options, let me check the fourth option. So it will be a waste of time. So yes, time consuming. So that's why you should be quick in grasping it in the exam. All right. Let's move to the next question, which was asked in 2024. All right. The given circuit, the terminal voltage in that cell, this is the cell, 3 volt, 1 ohm is the internal resistance. Question is, what is the terminal voltage? Now, as you can see, these are two resistors. They are connected sideways. Basically, they are in parallel. So the equivalent will be R1, R2 divided by R1 plus R2. 4 4s are 16. 4 4 plus is 8. 16 by 2 is basically 2 ohms. So the simplified circuit will be, I will have this battery of 3 volts and this internal resistance of 1 ohm, and that is now connected to basically an external resistance of 2 ohms. Now we can easily figure out how much current is flowing in the circuit. That current will be the total voltage by the total resistance. Total voltage by total resistance, like it was shown over here. Where is it? Here. The current will be EMF by external resistance plus the whatever internal resistance is there. That will be the current in that particular circuit. All right. The voltage is 3, external is 2, internal is 1. So this will be 3 by 3, which is basically 1 ampere. Now the question is to figure out the terminal voltage. The terminal voltage formula is E minus IR. E is nothing but 3, current is nothing but 1, internal resistance is 1. So 3 minus 1 is basically 2 volts. So 2 volts is option number 1. Is that right? How many of you got your 2 volts? Hi HV, welcome. No, if this is the first time, Ibrahim, this is not going to be completely enough. Like I said, you will have to have some basic idea at least. First time, everything, tuck, 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 1 hour, you will also get confused. But yes, this is a good start for the current electricity chapter for all the students who do not have confidence. This is a lecture which you can start off with. You will have to watch more lectures which is kept freely on the channel. Okay, please watch those classes. That will give you full super duper confidence, because you cannot, like I said, this is just 5-day challenge, but that does not mean you should stop the challenge after 5 days. You cannot sit cool and I will relax, I'll play games. After that, you have to continue. This is to build that momentum. Okay, I'm building that velocity. You have the mass, I'm building that velocity today. Right. Moving on to the next question coming up on your screen, and here it is. Two EMFs are there and they're connected to some resistance. The internal resistance are R1 and R2. The voltage across the source having internal resistance R2 is 0. Then, interesting question, start off by drawing the diagram. So basically what is happening, two sources are connected to external resistance. So imagine this is a battery of equal EMF. Okay, this and internal resistance is R1, such that this, and it is not mentioned whether they are in the same direction or whether they are in the opposite direction. So we will have to assume something, maybe let's say same. Most likely it will be same, or else they would have mentioned that they are opposing. So this is R1, this is R2, let's say, and now they are connected to an external resistance like this R over here. It is mentioned that the voltage difference across the source having internal resistance R2 is 0. So this is basically 0 volt. That is what is being mentioned. It is 0. Question is, what is the relation between the resistors? First of all, let's figure out How much current will be flowing? That will help me with the solution. So current is nothing but the total EMF, by the total resistance. You can see the EMFs are basically adding each other up. Both these EMFs are in the same direction, so they will add up each other. So it will be E plus E. Total resistance, this, and this. So it will be R1 plus R2 plus R. Okay, so that is basically 2 times E divided by R1 plus R2 plus R, of course. That is the value of the current. Now, talking about the terminal voltage is EMF minus I into internal resistance. Terminal voltage is 0. EMF is basically E. Current is basically this particular whole thing over here, which is 2 times E divided by R1 plus R2 plus R, multiplied by internal resistance. Internal resistance is basically R2. Okay, shift this guy over here. So you will get 2 times E divided by into R2 divided by R1 plus R2 plus R is equal to E. E will cancel. So 2 times of R2 will be, take the denominator on the top, R1 plus R2 plus R. Okay, so bring R2 on this side. So it will become 2R2 minus R2 minus R1 will be R. So therefore R will be R2 minus 1 is just 1. So just R2 minus R1. So R will be R2 minus R1. That is obviously option labeled D. Is that right, everyone? So this is how you have to solve the questions. That is how you become a Sigma. I'm showing you the expertise needed. I'm showing you the level that you have to achieve when you're solving mock tests. Here, though, I'm even talking, I'm explaining. But in the exam, you're not explaining, you're not talking, you don't have to show it to anyone. You're doing it for yourself. So your speed will be even faster than this. Is that right? Yeah. All right. Now, Ekalavya will be available or not? Yes, I will tell you, Gayatri, very soon on 5th of November. That surprise will be revealed to you. Okay? Great. Moving on to the next question coming up on your screen. A battery of mobile phone is rated at 4.2 volts, 5800 mAh. How much energy is stored when it is fully charged? mAh is given, milliampere hour. Question is how much energy is stored inside this particular battery. Voltage is also mentioned. Now, see, this is volts. This is volts. This is mAh, milliampere hour. So this is 10 to the power minus 3. This is ampere, and hour is nothing but 3600 seconds. What happens when you multiply voltage with current? What happens when you multiply volts with current? Basically, voltage into current will give me power, which is nothing but joules per second. It will just give me joules per second. And when you multiply that second with this joules per second, what are you going to get? Just think about it. When you multiply these two together, what are you going to get? You are just going to get the answer in joules, which is nothing but your energy. So all you had to do is just multiply these numbers. That's all, my dear warriors. So let's see what do we really get. So energy stored in the battery will be 4.2 volts multiplied by 5800. Milli means 10 to the power minus 3. Ampere is there as it is. Hour is 3600 seconds. That's it. So you just have to take the numbers like 4.2. I'll write it as 42. I will write 58. 10 got swallowed with the decimal. So 10 is there here. And 2 more zeros here. But 3 zeros and 10 to the power minus 3 will get completely swallowed and we'll just be left with the number 36. So 42 into 58 into 36 will be the answer. But in joules, if you want the answer in kilojoules, whatever this is, 42 into 58 into 36, whole thing divided by 1000 so that you get the answer in kilojoules. Just check it out. How much are you getting, my dear warriors? Yeah, just try it out. How much roughly are you getting it? if you want, you can do some rough calculations. Like 58 is close to which number? 60. 58 is close to 60, 40 is close to 40, 42 is close to 40. So you have 40 multiplied by 60. 40 into 60, how much will it be? 4 6 are 24. So 2400 approximate, chumma, random, I'm taking some approx values, okay? And into 36, into 36. So you can do one thing, just think about 24 into 36, right? So you can just say it is almost like 25 into 35 approximately. You can increase one and decrease one, or just see 24 into 3 will be how much? 72, and 24 into 4 will be nothing but 96. So it will be between 72 and 96. In fact, it will be slightly closer towards 96. So closer to like 85 or 90 or something. So I think it will be around 85 to 90. So I'm guessing the answer is number 3. So let's see. Yes, it is 87.7. You don't have to sit and actually calculate. That's my point in the examination. That's how you will solve. That's how you will solve. Yeah, got it? Understood? Did you understand? I did not do the calculation. Students ask me, sir, how to calculate very fast? And then students browse Vedic maths, abacus, and this and that, and they are doing like this, like this, like this, and all, looking like one retard. Guys, you don't have to sit and calculate exact values every single time. Even if you get approx values, na, more than enough. I know this value, okay, because after doing this 0 will get cancelled. I know it will be somewhere close to 85, 90 units. So that's it, done. Yeah, got it? Okay, perfecto. Let's go, guys. Next question on your screen, and here it is. There are n number of identical bulbs, and each is designed to draw a power of P independently from the main supply. They are now joined in series across the main supply. The total power drained by the combination is okay. There are n number of identical bulbs. Each is designed for power P independently means what? For connected, they are, if they are connected to a source, let's say standard source of V volts, they will draw that P power from that supply. Now, if they are joined in series, then what is the power? So here is the logic. I'll do one thing. I know if they are connected in series, their effective resistance will be nothing but R1 plus R2 like that till Rn. But all the resistors are same. So I will write it as N times of R. That will be the net resistance in series. Is that right? All of them are same because they are identical bulbs. Each bulb is like a resistor. So think of it like this, as if I have a resistance and I have connected it to the voltage V, and the power which is being lost or power being consumed is P. So P will be V square divided by R. Therefore, R will be V square divided by P. So R is nothing but V square divided by P. That's what it is. This is N times. So what is that effective resistance going to be? That effective resistance will be same voltage square, but this will be the new power over here. V square by the new power. Just like old resistance gave me V square by old power, new resistance will be that same voltage, same supply by the new power. Did you get this trick? Same voltage. It is drawn by the same voltage. Keep it in mind. So V square will cancel. So 1 by new power will be N by P. So the new power will be P divided by N. Will be just P divided by N, which is option number 3. Lot of students say NP. I have seen that common mistake. -1 minus marks we will get. Okay. Yeah. All right. All right. Sir, in the previous question, we took V as 3. We have to find it. In the previous question, voltage, we took it as... No, it was given. No, 4.2 volts was given. Yeah, 4.2 volts was given. I just used that. And if you talk about any other previous question before this, there was no value given. Here, 3 was given. In this case, 3 was given. You can see 3 was given. And that is EMF. It is not terminal voltage. Be careful. That was not asked to be found. EMF was not asked to be found. Terminal voltage was asked. So terminal voltage is between this point and this point, not these 2 points. It's inside the battery. the voltage as well as the EMF as well as the internal resistance. So this is terminal voltage, only this much is the EMF. I hope you understood the difference, Manoj. Okay, oh, sorry, Vibe, I guess. Vibe 004. I hope that is very, very clear. Let's go to the next one coming up on your screen. Yes, ammeter, voltmeter. These are the last few topics which have been repeated again and again. Let's do this. Mind map. Isn't this mind map amazing, guys? You're going to get it. Don't worry. Starting off with Wheatstone's bridge. Wheatstone's bridge is basically a combination of 5 elements in which 2 resistors are in the same ratio as the 2 other resistors, because of which the 5th component becomes useless. You can throw it into the garbage dustbin, okay, and you can simplify the circuit. Based on that, you have the meter bridge, which helps me calculate an unknown resistance by using a galvanometer. Let me show you both of these things, starting off with Wheatstone's bridge. So as you can see, these are our resistors, and there is some 5th element which is there in that circuit. There is some external supply. The current will go like this. It will get distributed in the 2 branches before coming back here. Now, if this by this resistance R1 by R2 is equal to R3 by R4, then whatever is here is useless. Whether it is a galvanometer, voltmeter, ammeter, wire, resistor, capacitor, it is useless. Forget it. The moment you forget this, you will see both of them are in series. These both are in series and their combination is in parallel, which makes the circuit easy to solve. So that is called as balancing the galvanometer, balancing the Wheatstone's bridge. Okay, and when it is balanced, it is a very easy and simple circuit. Most of the times you are going to get that. Okay, very, very important. Now this is used to measure some unknown resistance, meaning imagine I have this galvanometer over here which detects current, and somehow it is able to show 0 current. That means it is useless. No current is flowing. So if I know R1, if I know R2, if I know R3, I can find R4. So that is exactly the point. If I know any 3 of these, I can find the 4th resistance. So it is used to find unknown resistance, and that is the working principle of a meter bridge. So the meter bridge is exactly based on the Wheatstone's balancing principle. So you take a potentiometer wire which has some resistance. If you cut it in between, or if you take a point in between somewhere, this much part is one resistance, the other part is other resistance. You can place another resistance here and some unknown resistance over here. If you connect a galvanometer and if you touch it appropriately at a point, you will see this resistance by this resistance will be sometimes this resistance by this resistance. So then it is balanced when it shows null or 0 deflection. And then using our formula for meter bridge, R1 by R2 is R3 by R4, you can easily find whatever is the unknown resistance. Okay, either this is unknown or that is unknown. It depends what is given in the question. Sometimes this is also called as the balancing length. Balancing length because the Wheatstone arrangement gets balanced. It shows 0 deflection. If this is 1 meter, if this is some L meters, this will be 1 minus that L meters. But usually you use centimeters in such setups. So 1 meter is 100 centimeter. So if this is L centimeters, if this is 100 centimeters, this much will be 100 minus L centimeters. Is that okay? That is how it works. So the final formula which comes for the unknown resistance is, X, the unknown resistance is, so if unknown resistance is there, R into L by 100 minus L. Now here I think the nomenclature is little bit screwed up. So let me just write it down over here. So let's say this is my unknown resistance and this is my known resistance. Yeah, X is my unknown resistance, R is my known resistance. So I want to find this out. So use this formula, R divided by this length by this length. This is 100 minus L. Is that absolutely clear? Yeah. Yes, you can also use, the voltage across this. The voltage across this, is basically voltage gradient into length, and you can solve it by those methods also. But those are very few problems which are there like that. But yes, you can definitely do that. I mean, at the end of the day, you can say that the voltage across this X resistance is the same as the voltage across is same as the voltage across this balancing length L, and that is nothing but the voltage gradient, voltage gradient, voltage gradient, whatever symbol you want to use, lambda, rho, etc., multiplied by the balancing length. Voltage gradient is nothing but how many volts is there per meter, length is in meters. So when you multiply both of them, you will get the answer in volts. You will get the answer in volts. This voltage is same as this voltage. This voltage is how much volts is there per meter into those L meters will give me the voltage over here. That also you can use at times. Okay, perfect. I think it's good time now to go to the two devices, voltmeter and ammeter, guys. Yes, we are 10 minutes away and almost nearing, because after this Diksha ma'am will start and we have to solve some questions. So guys, let's go full focus, full power mode on. Okay, voltmeter. Voltmeter is a device used to measure the voltage across a device. So you connect it in parallel. So you do not want lot of current to flow through it. So that is why it is made of very high resistance. And the manner in which you achieve that high resistance is by connecting a resistor in series with that device which shows fluctuation or deflects. That is a galvanometer. So that is why you will see that for a voltmeter, you will see that you will connect a resistor in series. See, this is a voltmeter, this is a galvanometer. You will connect a resistor in series to improve the resistance to a very high value. Okay, very high resistance. Okay, you can measure the voltage, and in order to check the range, all you need to make sure that the current which is passing through it is within the safety limits, the maximum deflection current. This is a formula given, but you don't need this formula where V is the range, I is the maximum current which can flow, G is the resistance of the galvanometer, and R is the resistance that you connect in series. You don't need to use this formula every single time. You can just apply it logically like a series parallel circuit. I will show it to you by the example. Next, ammeter measures the current and it is passing through a device, so you connect it in series, so it should not affect the circuit. So the resistance should be very low, and because it has a very low resistance, to make sure that the resistance is low, you connect a resistor in parallel to the galvanometer, because for parallel combination the resistance always reduces. Okay, so it looks something like this. You have the galvanometer, you connect a shunt resistance, parallel resistance, which makes up the ammeter. So most of the current will get bypassed, protecting the galvanometer, keeping the currents well under the safety limits of Imax or full scale deflection current. And that's how you're able to achieve that deflection and measure the current. This is usually the formula, but you don't need that if you're using series parallel logic. I'll show it to you how. Okay, let's do some questions coming up on your screen. You have a galvanometer of certain resistance. Maximum deflection is 20 microampere that you can get. How much resistance do you need to make it into an ammeter till 20 milliamperes? Just see how logically I solve it. Say, I want to measure till 20 milliamperes. So, this is 20 milliamperes, which is passing. Now, what I have in the front is a galvanometer. Galvanometer has a resistance of 200 ohms. This is my galvanometer. So I connect a parallel resistance like this, and that parallel resistance has, I don't know how much value. Okay, I'll just call it RS or R, whatever you want to call. And finally, all the current will come back over here. As you can see over here, the current will get distributed into two parts, one over here and one over here. The maximum current which can go through the galvanometer is how much? 20 microamperes. 20 microamperes. So how much current will go here? Out of 20 milliamperes, 20 microamperes will go in this. So remaining will be this much current. Guys, milli minus micro, the micro is negligible. So can't you say it is approximately 20 milliamperes only? This is negligible. Can you see that? Most of the times in such problems, you will see the second term will be negligible. Ignore it. So almost all the current is bypassing, hardly any current micro is minus 6 power of 10 is passing through it. Now both of them are in parallel, and we know what happens in parallel circuits. In parallel circuits, voltage is basically the same. Voltage is basically the same. Here I will put galvanometer, here I will put the shunt resistance voltage. So across the galvanometer, what is the voltage? Current into resistance. So 20 micro multiplied by resistance, which is 200. Across the shunt, how much is the voltage? I into R. So 20 milli into shunt resistance. 20 cancels. Micro is 10 to the power minus 6. This is into 200. Okay, milli is 10 to the power minus 3 into RS. So RS will be, take 10 to the power minus 3 here, it will become 200 into 10 to the power minus 6 by 10 to the power minus 3, which will become 200 into 10 to the power minus 3, which will make it 0.2 ohms. 0.2 ohms is option number 2. If you treat it like a simple series parallel arrangement, it becomes very easy to understand. Got it? Yeah, perfecto. Amazing. Let's go to the next question, where we have to figure out if you want to convert it into a voltmeter, then what will you do? All right, let's do this. We have a galvanometer of certain resistance. How much? 50 ohms. Okay, 50 ohms resistance. I want to connect a resistor in series. Okay, perfect. Like this. This is my voltmeter, so that I'm somehow able to measure a total voltage of 100 volts. 100 volts. And the safety limit for the current through the galvanometer is just 5 milliamperes. Can you not see both of them are in series? Can you not see both of them are in series? So in series, guys, the net voltage is nothing but whatever current, the same current will pass multiplied by the resistance in effective, the effective resistance. Voltage is current multiplied by resistance. How much is the voltage? It is 100 volts. How much is the current? 5 milli. Milli is 10 to the power minus 3. What is the resistance? It is 50 plus R. 50 plus R. Take 10 to the power minus 3 here. So it will become 100 into 10 to the power plus 3. The whole thing divided by 5 is equal to 50 plus R. Alrighty. So this will become 10 to the power 5. 10 to the power 5 means 10,000. No, correct? No, no, it will become 1 lakh. 1 lakh divided by 5. That will be nothing but 20,000. So 20,000 is equal to 50 plus R. Therefore, R will be 20,000 minus 50, which is 19,950 ohms. 19,950 ohms is option number 3. That's how you can solve it. That's how you can solve it. Is that right? So if you treat it like a simple series and a parallel arrangement, it becomes easier to solve these kind of questions. Moving on to the next one. For you have Wheatstone's meter bridge kind of arrangement. The effective resistance is how much? Well. As you can see, this and this, this and this, this and this, all of them are in same ratio. R by R, 1 is to 1, 1 is to 1, 1 is to 1. So this is like a Wheatstone, but in a slightly complicated looking form. So I can say whatever is connected in between them, like this one, useless. This one, useless. So what remains is these two resistors which are in series, which will become 2R. These two resistors in series, which will again become 2R. These two resistors in series, which will again become 2R. So you have these three 2Rs in parallel. So when these three are in parallel, the effective combination Rp will be 1 by 2R plus 1 by 2R plus 1 by 2R, which will be 3 by 2R. Therefore, Rp will be 2R divided by 3. 2R divided by 3. Now this parallel combination is in series with these two. So the effective combination will be R plus 2R by 3 plus this R over here. So this will become, LCM is nothing but 3. So 3R plus 2R plus 2R. So 3 plus 2, 5, 5 plus 2 is 7. So 7R by 3. So 7R by 3. Did we miss on something? Just check it out. Effective resistance between A and B, R and R is there. Okay, this was 2R, 2R and 2R. Yes, perfecto. Now when we take the LCM, yes, this will become 3. This, oh, by mistake I wrote 2 over here. Yeah, my bad. Sorry, this was not 2R, this was 3R. Okay, 3 plus 2 is 5. 5 plus 3 is 8. So this will become 8R by 3. So 8R by 3 is option number 2. That's it. That is the correct answer. Yes, perfecto. Perfecto, my dear warriors. Let's go to the next question, but this is homework question. Please try to solve it. Okay, I'm showing it to you. Find out the effective resistance between A and B. Again, you will see a Wheatstone arrangement and something will get vanished, eliminated from this particular figure. All right. Next question coming up on your screen. Here it is. Meter bridge is there, and for the left gap, 2 ohm is there. Unknown resistance in the right gap. The balancing length is 40. When you shunt it, what is the balancing length going to change by? Let's think about the diagram. The left gap is basically 2 ohm. This gap, I do not know how much it is. I'll call it X ohms. The balancing length is given. This is 40 centimeter. This will be 100 minus 40, which is basically 60 centimeters. We know the formula. R1 by R2 will be this by this. That means 40 by 60. So 40 by 60 means 2 by 3. So this is 2 divided by X. So 2 cancels. X will become 3 ohms. So the unknown resistance is basically 3 ohms. Now there is a second part of it. On keeping a shunt means parallel. This word means parallel. Okay, so you have that 2 ohms, you have that 3 ohms, which is that unknown resistance. You have kept another 2 ohms in parallel. So what happens is the balancing length will change. The balancing length will change. Question is, what is that change in the balancing length? So this is L. This will be obviously 100 minus L. So first of all, these two resistors together, what will it be? That will be in parallel, right? So R1 into R2 divided by R1 plus R2. 2 3s are 6, 2 plus 3 is 5. 6 by 5 means 1.2 ohms. So therefore, in this particular case, this resistance by this resistance, so 2 divided by 1.2 will be L, this by this, L divided by 100 minus L, cross multiply. So 200 minus 2L is equal to 1.2L. Take that 2L, I believe, on the other side. So 200 will be 2 plus 1.2, that will be 3.2L. Therefore, L will be 200 divided by 3.2. That's it. So the question was to figure out what is the change in the balancing length. So the change in the balancing length will be nothing but your 200 divided by 3.2 minus the old balancing length, which is 40. So whatever answer you are going to get, just check it out. How much are you getting? Yeah, come on, my dear warriors. Just check it out. I have seen the answer. Yes, 200 by 3.2 is 62.5. See if you are getting this as 62.5. 62.5 minus 40, which will make it 22.5 centimeters. So 22.5, not 62.5. The question was, how much does it change by? Not the new balancing length. They have asked, what is the change of the balancing length? Yeah, perfecto, amazing. So that was your homework question. Now, please keep in mind, yes, Kirchhoff's laws are also very important. I have just kept the slide over here. Like first law based on the conservation of charge, which is current law. So whatever current enters in, will the current be going out? So current in is equal to current out. I1 plus I2 plus I3 will be I4 plus I5 plus I7, depending on who is entering, who is exiting, entering on one side, exiting on one side. That is based on conservation of charge, applied at a junction where all the currents, are joined together. Second law is based on the law of conservation of energy. It is applied for a closed loop in a circuit. It could be a complex circuit. You start going along some path, but you come back. Every place you will encounter some voltage difference. Some places it will increase, some places it will decrease. If you add those voltages after you come back, you will see that total sum will be zero, because voltage difference between this point and this point will be zero. Same point. What is the voltage difference of the same point? Zero. So it is based on conservation of energy. And remember, whenever you have to measure the voltages, it depends which device it is. For a battery, the voltage is E. For a resistor, it is IR. And for a capacitor, it is Q by C. Keep that in mind. All right. So for a battery, it is E. For a resistor, it is IR. And for a capacitor, it is Q divided by C, because Q is CV, so V is Q by C. Correct. And it also depends on who is higher and who is lower. Like for the battery, this is higher, this is lower, this is higher, this is higher if this is a positive charge, and this is higher if the direction of the current is like this, because current always goes from higher voltage to lower voltage. So this is negative, this is less. If this is negative charge, this will be at a lower voltage. So how you are moving across those devices decides the sign, whether it is negative or positive. Okay, plus IR or minus IR. For a resistor only, main problem happens. Think always in the direction of the current, you are going from high voltage to low voltage. So voltage will drop, so it will be negative IR. If you are going from minus to plus, you are climbing, so it will be plus IR. Okay, so that is for your Kirchhoff's voltage law. Perfect. So that was your lecture, my dear warriors. We have taken, I think, 1 hour, 5 minutes roughly. So all the best. Now it's time for chemistry and then mathematics. Stay tuned for more such classes. Quick revision, quick concepts, application, no wastage of time. These are your power punched sessions to become a Sigma warrior from a noob warrior, right? So thank you for liking, and please comment below. Day 1 completed. Day 1 physics completed. Similarly for chemistry, day 1 chemistry completed. Day 1 maths completed, right? And after 5 days, you complete the challenge. You have to put up, yes, Sigma warrior finally, right? So don't lose hope and don't give up this challenge. Just 5 days, I'm asking you, please give me those 5 days. Okay, bye bye. Take